There we go. So we have so we need to understand what is this ICMP. It's a very, it's a very important protocol, right? ICMP is a very important protocol which has been designed to compensate for two important deficiencies of the IPv4 protocol. Okay, IP protocol basically. So this IPv4 has two deficiencies. One is that it doesn't have any mechanism for error reporting, and it also doesn't have any error correcting mechanism. So error reporting, error correcting, and also that it lacks the mechanism for the host and management queries. So what it means, host and management queries means like so if you want to know the status of a particular host, right, so that basically whether it is alive or not, etc. So that sort of thing you cannot really know using IP protocol. IP protocol doesn't give you that facility. So in order to compensate for these deficiencies, a protocol called ICMP, Internet Control Message Protocol, was designed. So this ICMP has two main functions. One is to handle error reporting, and the second is to handle queries. So error reporting messages and query messages are basically two types of ICMP messages. Error reporting messages basically, as this name suggests, that if a particular router or a host encounters some problem, right, while it was processing an IP packet. So what it can do is it can generate, the ICMP protocol can help generate these error reporting messages. Okay. The query messages basically can help the host or the network manager get specific information from a router or another host. So it can query like from a router or another host, so what is this, if it needs any kind of information, so it can, so whether it is alive or not, or whether it is reachable or not, like that, so those kind of information it can get. So for example, the nodes can discover their neighbors. Also hosts can discover and learn about routers on their network, and routers can help a node redirect their messages. Okay. So these are basically within the purview of ICMP. So as I told you that there are two main classes of messages in ICMP. One is called the error reporting message, the other one is called the query message. The corresponding packet structure basically, it's shown over here. Okay, this message structure, basically the message format is shown over here. The corresponding fields are also given over here, but in the interest of time, I'm not going through each of them in too much of detail, but I would like to mention a couple of things over here. So if you are talking about a particular IP datagram, right? So it's going to have the header, which we have seen, and it's going to have the data, right? It's going to have the data. Now, so what this ICMP does is it puts another header, okay, like this. The ICMP packet is going to have on top of this IP header, it's going to along with the IP header, it's going to have the ICMP header, and then it will send the IP datagram out, right, with that. So this ICMP header, that this is the one which is going to contain the information about whether there is any error that has happened, or whether it wants to know certain information from another host or router, as I said before. So for this, basically this header is basically added by this ICMP protocol. So what are the possible, so what sort of information does it carry, right? So what sort of information does it carry? So it carries information, for example, any kind of these error reporting messages. For example, if the destination is unreachable, then the error reporting codes that are used are 0 to 15. Then there is something called source quenching, which has code 0. I'm going to tell you what is source quenching very soon. Redirection, basically, if a packet has to be redirected, right? The codes that are used belong to 0 to 3. Time exceeded, codes 0 and 1. Parameter, some other parameter problem, codes 0 and 1. Query message, so echo request and reply, basically only code 0. Timestamp request and reply, that's also only code 0. So these are actually basically these different codes that are used along with the different types, these types of messages, right? So destination unreachable, source quench, these are the different types of messages. So 3, 4, 5, 11, these types are also numbered, right? So like that. Now let us look at the error reporting messages. Okay. ICMP basically uses the source IP address to send the error message to the original sender of that particular datagram. So what it will do is it is going to put the message as a header, ICMP header, and that particular message, that particular packet is going to be sent by ICMP to the original IP, to the source, right? Why does it send it to the source? Because it has to inform to the source that this is the problem that the packet that you had sent encountered en route. Okay. So ICMP basically follows some rules in reporting the messages. So first, no error message will be generated for a datagram having a multicast address or special address such as this host or loopback, right? So you know that the loopback address. So by now I think you are all familiar because you are doing the lab. Second is that there is no ICMP error message that to be generated in response to a datagram carrying an ICMP error message, right? So for a particular ICMP error message, there is no other ICMP error message that will be generated. And third is that no ICMP error message will be generated for a fragmented datagram that is not the first fragment. So these are some of these rules that basically ICMP uses. So let us look at these different types of error messages, different types of messages that can be supported by ICMP, that are supported by ICMP. So the first one was what? Destination unreachable, right? So this was the one, destination unreachable, codes 0 to 15. So let us try to see. So this particular message basically uses the codes 0 to 15 to define the type of error message and the reason why a datagram has not reached its final destination. Okay. So for example, code 0 will tell that the source, tell the source that the host is unreachable. So like this, basically, please go through all of these. I'm not in the interest of time, I'm skipping this. So then the source quenching basically, so through this, basically you inform the sender that the network has encountered congestion. Okay. And the source needs to slow down the sending of the datagrams. So to slow the source down, basically this source quenching information message basically has to be sent by ICMP to the original source, right, which is sending the packets continuously. Okay. Now then comes the redirection message. Okay, so which is type 5. It is used when the source uses a wrong router to send out its message. So I told you, previous lecture, basically I showed you a case where say the message lands up in a different network, right? Not the correct network, so it needs to be redirected, right? So for this, ICMP can be used to redirect the message to inform the source that it has come to the wrong router. So there could be some parameter problems also, and so on. So like this, basically there is the query message, right? So these were the error messages, the previous ones that we covered so far are the error messages. There could be some query messages also. So as I was telling you, like these query messages are used to query or probe or test the liveliness of hosts or routers in the internet. Okay. So for this, basically you find the one way or the round trip time for the IP datagram between the two devices, or even find out whether the clocks in the two devices are synchronized, right? So for querying, basically there are different tools that are used, right? So I will show you shortly, so what sort of tools are used, because these query messages are very important in debugging. So I was talking about the debugging. That means that something has gone wrong somewhere, right? So, or you need to really understand whether what is the status of the different connected hosts or the routers in the network. So for this, basically there are a lot of network debugging tools that are available. So two such very popular tools are the ping and traceroute, very popular, right? So this ping and traceroute, they use the ICMP protocol for this debugging purpose. Okay. So ping, basically what it does is it measures the round trip time for messages sent from the originating host to a destination computer that has echoed back to the source, right? That are echoed back to this. I will show you actually what, how, I mean, in case you do not know ping, I'm going to show you very shortly. Traceroute is basically another tool which uses ICMP for displaying the possible routes or the paths and measuring the transit delays of packets across an IP network, right? So these two are two very important tools. Now let me quickly show you how you can, so I'm not in the Linux right now, but I'm going to show you in Windows only how these could be used. Sorry, let me just change over here. So not this one. So let me. Okay. Can you see my command prompt screen?
Yes,
Okay.
sir.
Yeah. So I was telling you that there are two of these debugging uh, protocols, as you can call, or you can call them as tools, right? So one is the ping, right? So what you can do with ping, I think many of you have already done it, right? So this is a very popular protocol that is used, which uses ICMP. So ping something, right? So let us say that we want to ping www.google.com, right? So you see that it shows that pinging www.google.com, it has resolved, right? So it has resolved to this particular IP address with 32 bytes of data. So 32 bytes of data sent, right? So reply from this, so you get the replies, right? And you see that TTL value, time to live, so is also shown. So how much time you are going to get, right? So you see like this. So finally the statistics for this packet that is sent over there, so the packets, how many packets were sent? There were 4 packets that are sent, right? So sent 4 packets, received 4 packets. So sometimes, so let us say that you type in something else, right? So ping something, so which let us say doesn't exist, or which is not up and running. So let us give it something, so one so 10.10.10.1, let us call it. You see that, so after some time this pinging is going to time out, right? So it will request timeout. So from this you know that this is not reachable. On the other hand, this was reachable, and that means that, so from my host, basically this particular IP address is basically reachable, right? So it basically shows that, so there is no reason why we'll not be able to send some information, or we'll not be able to connect to this particular. So this is a popular debugging tool that is used. The other one that is used, so it will give you all the statistics at the end, right? So like this, actually it will tell you all this is packet sent, received, lost. So 0% lost, right? So which means that everything is fine, right? And how much is the round trip time in milliseconds? Yeah, so minimum, maximum, average round trip time that it took is also given. So this is one is ping. The other one is the trace route. Trace route, ROUT. This trace route, basically I do not have the Linux machine with me, but so I'm doing it from Windows. So in Linux, basically you can use the trace route command uh, just like that. So basically this trace route basically can help you to understand so how a particular host or how it is connected to the other hosts, right? So what are so that means that what router etc is connected to it, right? So the so as I was telling you that in Linux basically this trace route is used as the command, and in Windows it is trace RT. Trace RT. So this is the command, and the different options, and so what sort of so the so this is the command to be used, and the different options that are there. So these are also given over here. Okay. So basically, using this, you can trace the path that a particular packet is going to take from the source to the destination, right? That is the whole purpose of this trace route. Okay. So basically, so the different IP addresses that a particular packet, which is originating from a particular host, it's going to take, all the routers that are going to be visited along the path. So these are all going to be, you can come to know using this trace RT or the trace route command, right? Okay, so play around with these, but so these are two very important commands basically, or protocols that are used, which use ICMP to get the work done. Okay, so we are going to stop this part as well. Any question? Any question, please?